Today I'll be looking at section 11.3. Our essential question is, how do you solve radical equations? Here's a few reminders. In this chapter we're only using positive square roots. Here's some vocabulary and a math property. Here are the steps for solving a radical equation. Note you always should check your answers. And the reason for that is because there might be extraneous solutions. Our first example is one where we're actually going to determine whether the given value is actually a solution to the equation. In this case, our given value is -1. So what we are asked to do is to plug it in for x to see if it works. Using order of operations, I need to work underneath the radical, first multiplying and then subtracting. Right here I can tell that this is not going to work. We are not allowed to take the square root of a negative number. If I had continued on this side, you can also see that it doesn't work, but right here you should have been tipped off that it's not possible. So no, -1 is not a solution. In the next example, I'm actually going to solve a radical equation. The first step is to get a radical all by itself. In this case we have 2, so we need to get them to opposite sides. So to do that I'm going to add the square root of x to both sides. And then your next step is to square both sides. Remember that squaring a square root cancels. And then solve for x. And then check your answer into the original equation. There's my original equation. I'm going to plug 1 in for x. Use order of operations. And that is true. It checks out. So 1 is the solution. Here's our next example, where the square root of 6 minus x equals x. You want to get your square root alone. In this case it already is, so we can go ahead and square both sides. Squaring cancels that square root. So I have 6 minus x equals x squared. I notice that I have the variable twice, but this one's to a power of 2, which means they cannot be combined. So I have a quadratic here. And to solve quadratics, we need to get everything to one side of the equation. So I'm going to move both of these values to this side of the equation. And I would move my x value by adding it to both sides, so it's going to be positive. And I would move that positive 6 by subtracting it. And I would have nothing left on the left. From here, you can factor this equation. And then solve each factor. And don't forget to check both answers into the original equation. So this is going to be my check for -3. When you subtract a negative, that's actually adding. And actually right here, maybe you notice that you had a square root equal to a negative, so right here you might have noticed that this does not work, and down here you can also see that. So this is not a solution. It does not work. We also have to check our next one. And this is true. So the only solution here that works is the 2. So x equals 2. In our next example, I again already have my square root isolated, so I can go ahead and square both sides of the equation. This cancels my square root. And I'm actually going to square this off to the side. Remember, squaring means you're multiplying it by itself. You are not allowed to distribute that squared in there. So I'm going to be taking x plus 4 and multiplying it by x plus 4. I then use the FOIL pattern, which would give you x squared plus 8x plus 16. This is another example where you have a quadratic, so you need to move everything to one side of the equation. I'm going to have to add x to both sides, so that's going to give me 9x, and I'm going to have to subtract 2, which is going to give me 14. And again, you would factor this, or you can use the quadratic formula. Set each factor equal to 0 and solve. So it appears that we have 2 solutions, but we must check them. I'm going to start by checking -7 into the original equation. Notice inside that square root I have minus a negative. That's going to turn into a plus, and 2 plus 7 is 9. I simplify on that right side, I get -3. So I have the square root of 9 equals -3, and we're not allowed to have square roots equal negative numbers, so this is not a solution. I also have to check my next value. I'm going to cross off -7 here. I'm going to make sure that -2 does work into that original equation. This is going to turn into addition, so I have 2 plus 2, which is 4, underneath the square root. -2 plus 4 is 2, and the square root of 4 is 2, so this one works. So our only solution is -2. And here's my last example. Your first step is to isolate that square root. And you would do that by first subtracting 12. And then dividing by 4. Again, your goal is to isolate that square root, so I can do that by dividing the 4 off. Now that your square root is alone, you square both sides. And squaring cancels your square root. And then solve for x. and check your answer into the original equation. So I'm going to subtract 23 minus 7. That would give me 16. Take the square root of 16. Multiply, then add, always following order of operations. 16 plus 12 is 28, which is what we wanted it to equal. So that one checks out.